Hi girls, welcome back to the videos. So you can see here the video for today is inverse trig, and I think I told you that, whoops, in class. So, I don't know what I'm doing. So, we've talked a little bit today about inverse functions generally, and I hope you remember that. So what I've drawn there is I've drawn sine x, and I hope you remember that to find the inverse function and ignore like whether or not this is accurate in terms of scale, it doesn't matter for what I'm talking about here, but let's say that there is the line y equals x, because we know that to find an inverse function we reflect it in the line y equals x. And so I hope you can see now that when I reflect sine x in the line y equals x, so it should pass through the origin again, and it should look something like this, I think, and my scale is pretty bad there, right? But it should look something like this. And the thing we're talking about today with functions being one-to-one or monotonically increasing, so the idea is that if I just undo what I did then, and I'll do it again in a minute. So this function has an inverse when it is either one-to-one or monotonically increasing. Now if you remember, one-to-one basically means that if you've got an x value, you get one y value, and if you've got a one y value, you get one x value. Alternatively, if you just think about where is it increasing and increasing only, well, you could say in this section here, the curve is increasing and increasing only. You could also say that in this section here, the function is decreasing and decreasing only. You could also say that in this section here, the function is increasing and increasing only. And you could say something similar at this section over here. And the point is that the domain that you choose for the restriction is basically up to you. Now, I'll just go back and I'll draw in that inverse sine function, roughly. So it looks something like this. And so it has a range. And now the thing to think about is, if I said to you, well, I want y equal inverse sine x, right? Now, the idea is that sine x, you put an angle in and you get a ratio out. So the inverse function should be exactly the opposite. So this here will now be a ratio. Oh, stupid iPad. And this thing here will now be an angle. And so then you need to ask yourself, well, what are the angles that you want to be told when you ask for the inverse function of a sine? Well, I mean, for the most part, when we talk about angles in real world and in calculus world, we like to think about acute angles. So you'd want this section, wouldn't you? Right? Because this number here is pi on 2, because it is this point here reflected. So it's pi on 2, 1, because that's 1 pi on 2, and pretend you can't see the fact that my scale is now shocking. But anyway, it doesn't matter. Right? So you want acute angles, and you want a couple of other things if you're talking about a function, right? You want it to be continuous, right? So, I mean, basically, you need to pick another section that is running out of colours. But once you've picked the bit that we've picked already, the acute angles, you want to pick a section that gives you angles that are, sorry, let me say that again. We need this final function to pass the vertical line test, right? So I've basically taken this side here out of consideration. But if I draw a vertical line here, nothing is hit. So I need to put something over here. And hopefully it's fairly obvious that this is now the thing to pick, right? Because now I've got a continuous function, and I've covered as much as I can, right? And so I've taken from the original this green section of the domain, from minus pi on 2 to pi on 2, and from 1 to minus 1. That is the inverse sine function, and that is how we define it. Another way to think about, well, you could have kind of told me that already, if you just put some numbers in your calculator. Right? If you put this in your calculator with various ratios, and I'd encourage you to do it now, you will get positive numbers and you will get negative numbers, and they will be between pi on 2 and minus pi on 2. Right? They will be between, what, 1.6 and minus 1.6, basically. And it's worth doing that now, I would suggest. So I'll quickly show you how to do inverse cos before I wrap up for the day. So here's my curve of cos, something like this. Fantastic. And then let me change my colour. Purple sounds nice. So I draw my y equals x, and then I reflect it, and this is actually something that I don't feel I'm very good at, but I now reflect it in the deadline. I always do this point goes to here as my kind of helper. Right, so it's something like that. So that is going to be 1, because again my inputs are now ratios, minus 1. That's 0, that there is pi on 2. Believe it or not, that there is pi, but anyway, doesn't matter. So again, you want to think, well, what would a relevant range be? Alternatively, what would be a relevant domain for my original? Again, you want it to be positive. You want acute angles to come out, so you want that bit. Once you've picked that, you're not allowed to pick that, because now it's not a function, so I can't do that. And it has to be continuous, so it has to be that, right? And there's my inverse cos function. It looks a bit more like that, but anyway. Oh god, that was wrong. It looks a bit like that. And again, if you put, let me find someone right. If you put y equals inverse cos x, remember this is a ratio, output is an angle. That's what I was talking about before, acute angles being on the y-axis. If you put some inverse cos x in, you will get only ever positive numbers, and they will be between 0 and 3.14, 15, blah, 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 blah. And again, I would encourage you to do that now. We can also think about it in terms of the unit circle. Right? Oh, that's not right. Anyway, how does that work? Ooh, there we go. Right? Basically, you need two quadrants that are adjacent to each other, where cos goes from positive to negative. Has to be these two, right? I mean, you could pick... No, you couldn't. You could pick these two. Positive, negative, negative. But why would you? You know, why would you want negative angles or angles between 180 and 360 when you can have acute angles? Right? And that's the idea. You have to be rational about these things. Okay, so I'll show you the homework now, which is to memorize the following photo. And there it is. This one is a photo of my holiday project, which was a clothesline-like thing with some pot plants, and you can see a dog there whose name is Abby, you may recall. That was my holiday project this time around. So welcome back to the term, and I'll see you tomorrow for a double.